Hi everyone. Okay, so today in the B2 notes, we're going to be looking at solving equations and solving inequalities. In the first example, it says to check whether the given value of x is a solution to each equation. So we're going to take the value for x that we're given and we're going to plug it in for x. So you can see here in the first equation, I plugged the 4 in for the x, and now I'm going to simplify the left side of the equation and see if it equals 6. And 12 minus 1 gives me 11, and 11 does not equal 6. We're being asked to check whether the given value of x is a solution, and so for this one, we'll conclude no. No means that 4 is not a solution to that equation. And so in the next equation, we'll do the same thing. We're going to plug in the 2. And I'll simplify the left-hand side to see if it equals the right-hand side. So negative 4 times 2 is negative 8, and then negative 8 plus 3 is negative 5, and this is true. So the answer to this question is yes, 2 is a solution to this equation. We can use the properties of equality to solve an equation. Here I'll combine like terms on the left, and then I'll add the 3 to both sides. I'll divide both sides by 3, and so for this first one, I'll get x equals 4. Notice that on my next equation, I have variables on both sides. I'll start with the distributive property, then I'll minus the 2t from both sides, add the 21, and then lastly, I'll divide both sides by 5. And my answer for this one works out to be t equals 3/5. You could write it as a decimal, but we'll just leave it as a fraction. On this next example, it says a mistake was made, and so we're supposed to circle the mistake and explain the mistake and then correct it. Looking at the problem, the first step that should have been done was subtracting the 2x from both sides. And so right here, that 5x, that's where the mistake was made. You can say they added the 2x instead of subtracting it from both sides. You can also say that they should have used the subtraction property of equality instead of the addition property of equality. And then here, we'll correctly solve the problem. And the correct answer to this question would be x equals 10. All right, moving on, this next example wants us to practice writing equations to model the scenario, and it gives us the reminder that we don't need to solve them. The perimeter of a rectangle is 76. Make a note that when you find the perimeter of a rectangle, you're going to add up the 4 sides. It says that the length of the rectangle is 3 more than 6 times the width. Here we can let our width be w, and so the length is going to be 6w plus 3. When we write our equation for this one, we're going to use just one variable. So the width plus the length plus the width plus the length would be equal to 76. We don't need to simplify this at all because it says it just wants us to write the equation. On the next example, one health club charges a $50 sign-up fee and then $65 per month. A second club charges a $90 sign-up fee, and then they charge $45 per month. You're trying to write an equation that you could use to solve the question, when would they be the same? So if we let M stand for months on this one, a $50 sign-up fee plus $65 per month, we want to find out when would that be equal to a $90 sign-up fee plus $45 per month. Again, we don't need to solve it, we're just setting up the equations. All right, so this next question has 2 parts. We're going to solve each of these radical equations, and then when we're done, it asks us to determine which of the equations have at least one integer solution, and the definition of integer is given up above. Remember that when you're trying to clear out a square root, you can square both sides. You just have to make sure the square root part is isolated first. So here I'll start by squaring both sides. The square root will cancel out with the squared, and then I'll finish by subtracting the 3 from both sides. I'll get x equals 22, and 22 is an integer, and so when I write my list of problems with at least one integer solution down below, I'll include A in my answer. On B, I need to move the 1 over first, then I'll square both sides. And so for this one, I'll get z equals 36. 36 is an integer, and so I'll include that in my list later. On C, I'll square both sides. I'll divide both sides by 4. On this one, the answer works out to be 49 over 4, which is not an integer, so I will not include this one in the list. On D, I start by subtracting the 11 from both sides. Here, the number inside a square root cannot equal a negative number, and so we say that this one has no real solution. Integers are real numbers, and so we will not include D in our list. On E, I'll start by squaring both sides. The square root cancels out the squared on the left. On the right-hand side, though, remember you need to FOIL. I'll combine like terms on the right. I'm also going to move the 2 variables on the left over to the right-hand side. And then from there, I'll factor to solve. The 2 numbers that times to give me 18 that add to give me 9 are 6 and 3. And then I'll use the zero product property. Here I'll subtract the 6 from both sides to get negative 6. And then on this one, I'll subtract the 3 from both sides, and I'll get negative 3. Remember, the directions on this one said at least one integer solution. Both of these are integers, and so I'll include E when I write my answer later. And then on F, I'll start by squaring both sides. And then I've got variables on both sides of this equation. I'll subtract the 3x from both sides, and I'll finish by adding 3 to both sides of the equation. And so for this one, I'll get x equals 5. So out of the 6 problems, the problems that had at least one integer solution were A, B, E, and F. C was a fraction, and D had no solution. All right, moving on. A literal equation is an equation that consists primarily of letters. When we're given a literal equation, we can be asked to solve it for a given variable. Coincidentally, both of these have us solving for h. So on the first one, I'm trying to get the h all by itself. I'll start by multiplying both sides by 3 to clear the fraction. And then in one last step, I can finish the problem. I'll divide both sides by pi r squared. They cross out on the right-hand side, and I'm finished. On these questions, you know that you're done when the letter it asks you to get all by itself is by itself. On the next one, I'm also solving for h, but notice that the h is in 2 places. So I'm going to start by factoring out an h. Once the h is factored out on the right, I just need one more step to get the h all by itself. I'll divide both sides by b plus 2 pi r. The b plus 2 pi r crosses out on the left-hand side, and I'm done. Remember, on these, you know you're finished when the letter that you're asked to get all by itself is all by itself. All right, a solution to a linear equation is a coordinate that satisfies the equation. So in this first example, what do the points on the graph represent? The points on the graph represent the solutions to the equation. Looking along the line, you can pick out points, and it might help you to darken them like that. You can pick out points that are whole number coordinates on the graph. In part B, we're asked to name 3 solutions to the linear equation, and you can name xy pairs for any of those points that we just drew on the graph. So -3, 0 is one example, 1, 2 would be another, and 5, 4 would be another, although there are different points that you can select as well. All right, the next one here says the function t of d is equal to 10d plus 20 gives the temperature. The first one wants us to figure out the temperature at 24 kilometers. 24 kilometers is the depth, and so we're going to plug that in for d. So I'll plug it in for d, and then I'll multiply first, and then I'll finish by adding. So for this one, at 24 kilometers, I'll get that the temperature there would be 260 degrees. The next question is a little bit different because it tells us the temperature and it wants us to figure out the depth at which that temperature occurs. So for this one, you're not going to plug the 810 in for d, you're going to set the equation equal to 810. Think about it like you're trying to figure out when the equation would equal 810, or what number you would have to plug in for d so that the equation equaled 810. I'll subtract the 20 from both sides, and I'll finish by dividing both sides by 10. And so for this one, I'll get d equals 79. So the answer is that that temperature would be reached at a depth of 79 kilometers. Inequalities are different than equations because they represent a range of numbers. In this first example, it asks us to translate the sentences below into inequalities. In A, a school bus can seat at most 50 students. If we let S stand for the number of students, at most 50 means that it can equal 50 or it can be less than 50. So this inequality, S is less than or equal to 50, would represent this scenario. In the next one, children must be at least 48 inches tall to ride the roller coaster. If we let H stand for their height, on this one, their height needs to be either equal to 48 or greater than 48. And so their height would need to be greater than or equal to 48 inches. At most was the important phrase in the first one, and at least was the important phrase in the second one. Moving right along, in the first one, to write an inequality that represents each graph, it's a closed circle. X is less than or equal to positive 2. Or equal to because the value 2 is included in the solution set, and then less than because it's shaded to the left. On the next one, it's an open circle. X is greater than -3, not or equal to because -3 is not included in the solution set, but greater than because it's shaded to the right. Solving inequalities is just like solving equations. So here in this first one, I'll add the 3 to both sides. And so my solution for this one will be A is less than 8. On B, I'll subtract the 1 from both sides. And then generally speaking, when we write our answers to inequalities, we usually flip them so that the variable is on the left-hand side. So on this one, when it changes, the whole thing flips around. So C is greater than or equal to 1 is the solution set for B. C has a few more steps. I'll start by doing the distributive property, then I'll combine like terms. I'll add the 4 to both sides, and then finally I'll divide both sides by 2. And so for this one, I'll get P is greater than or equal to -7/2. There's a reminder included down here that will come up in the last one. So when you multiply or divide both sides of an inequality by a negative number, the inequality sign changes direction, and that's going to happen on D. I'll start by subtracting the 4 from both sides, and then here to isolate the x, I'll need to divide both sides by a -1. And so on this one, I'll get x is less than -4. The inequality sign changes directions because I divided both sides by a -1. The last page of notes has some practice with graphing linear inequalities. The first one wants us to write the inequality that's described by the graph. Notice that this one has a solid line, not a dashed line, and that it's shaded under. That will help us determine the type of inequality symbol. I also need to identify the y-intercept, which here is -6. And then lastly, I need to count the slope on the graph. And on this one, it's going up 3 and 1 to the right. My rise over run is 3 over 1. We can write our answer in slope-intercept form, so the y comes first. Less than because it's shaded under, equal to because it's a solid line, 3x because the slope is 3, and then -6 because the y-intercept is down at -6. And so this would be the inequality that represents that graph. We're given the inequality. Notice that it's not in slope-intercept form, and we're asked to graph it. So one way you can accomplish this is by putting that inequality into slope-intercept form. I'll minus the 3x from both sides, and then I'll divide both sides by -2. Remember here I'm dividing by a negative, so the inequality sign will change direction. So I get y is less than or equal to +3/2 x minus 3. I'll start by plotting the points that are on my graph. So here's my y-intercept, and I go up 3 over 2 and continue. I'll go back to my y-intercept and count the opposite direction. It's less than or equal to, so this one will be a solid line. And then lastly, I'll shade the correct side of that line. Less than or equal to means I'm shading under the line. We're asked to name a point that is a solution to the inequality. You can pick any point from the shaded region. An example of one such point would be 5, -3, but there are many answers. We're then asked to name a point that's not a solution to the inequality, so that would be any point in the unshaded region. And so one example of such point would be -2, 4. But again, there are many correct solutions for that as well. To answer question C, we need to determine whether these points are in the shaded or unshaded regions of the graph. 5, -4 would be a yes, because that point is in the shaded region of the graph. -3, -2 would be a no, because that point is in the unshaded region of the graph. And then lastly, 0, -3 is a point that's on the line. Because this is a solid line, the boundary line is included in the solution set. So the answer to this one is yes. However, it's important to point out that if it were a dashed line, the answer to part 3 would be no. Looking at the last two questions here, yes, the boundary line does intersect the x-axis. It crosses the x-axis at the point +2, 0, so that would be your x-intercept. And then finally, the boundary line also does cross the y-axis. It crosses at the point 0, -3, so that point is your y-intercept. All right, this last question has a couple parts. So it's $6 per adult ticket and $3 per student ticket. They're hoping to raise at least $1,200. X is for adults and Y is for students. So $6 per adult ticket plus $3 per student ticket, and they want to raise at least $1,200. So they want the profits from those sales to be greater than or equal to $1,200. You could graph this linear inequality by putting it in slope-intercept form, or you could graph this linear inequality by finding the x and y intercepts. So remember, to find the x-intercept, you're going to put a 0 in for y, and then 3 times 0 is 0, and then I'll divide by 6. So on this one, I'm going to get that the x-intercept is at the point 200. To find the y-intercept, I'll do the opposite. I'm going to put the 0 in for x. 6 times 0 is 0, and then I'll divide both sides by 3. So the y-intercept for this graph will be at 400. I have to pick my scale. Down here on the x-axis, remember this is for adult, I'm going to count by 20s. And then over here on the y-axis, remember this is for students, I'm going to count by 50s because I have to get up to 400 on that side. So my y-intercept is at 400, my x-intercept is at 200. I connect those points with a solid line greater than or equal to, and then I'll shade in the region of the graph that's above the line because they want to make greater than or equal to $1,200. We can plug the 100 in for x. 6 times 100 is 600, minus the 600 from both sides, and then divide by 3. So if they sold 100 adult tickets, they would need to sell greater than or equal to 200 student tickets in order to meet their goal. And then down here in the last example, it says, given that there were 160 adult tickets sold, give 3 possible values for the number of student tickets sold so that they reach their goal. There are a lot of ways that you could answer this question. You could definitely use the graph. I'm going to do it differently today though. I'm going to start by plugging the 160 in for x for the adult tickets. 6 times 160 is 960, minus the 960 from both sides, and then divide by 3. You get y is greater than or equal to 80, which means you would need to sell 80 or more student tickets. You can verify that by coming up here and looking at the graph. Right here for 160 adult tickets, you would have to sell anything greater than that point on the line, which looks like it's right at about 80. We are asked to state 3 solutions to the equation. There are many that you could state. Anything 80 or above would be an answer to the question. I picked 100, 150, and 200, but any other numbers that are greater than or equal to 80 would mean that ASB would reach their sales goal.